Hello and welcome, my dear students. Today, we are starting a very important unit of UGC NET Paper 1, that is Unit 9 People, Development and Environment. In recent examinations, examiners have started asking tough and concept-driven questions from this unit. That's precisely why we have carefully compiled this entire unit, based on recent exam trends and the new topics that have started appearing in the paper. Every concept we cover here has been asked in the exam over the past 10 years. Nothing extra, nothing irrelevant, only what truly matters for your exam. As always, you can download the PDFs from the app, solve topic-wise PYQs, and access last-minute revision notes for each chapter across all units. So without further delay, let's begin today's session. So, today we are starting a very important topic, Global Development Framework known as the Millennium Development Goals, commonly called the MDGs. These goals were introduced by the United Nations as a collective effort to address some of the world's most pressing social, economic and environmental challenges. The MDGs emerged after the adoption of the United Nations Millennium Declaration, which followed the Millennium Summit held by the United Nations in the year 2000. This framework marked a major shift toward goal-oriented international development, and many of its details have been repeatedly tested in examinations. To begin with the basics, the time frame for implementing the Millennium Development Goals extended from 2000 to 2015. This specific duration is a confirmed exam favorite, so make sure you remember it clearly. The MDGs were primarily designed for developing and economically weaker countries. Another point examiners often emphasize, structurally, the framework consisted of 8 goals supported by a total of 21 targets, both of which have appeared directly in exam questions. These goals were formally established during the Millennium Summit of the United Nations, and the deadline for achieving them was set as 2015, a detail that is frequently asked. Now let's walk through the 8 Millennium Development Goals, which were collectively endorsed by 191 UN member states, along with several international organizations. The first goal focused on eradicating extreme poverty and hunger. This goal aimed to reduce extreme poverty and global hunger by half between 1990 and 2015. If you're revising for exams, highlight this. This goal and its objective have been directly tested multiple times. The second goal aimed to achieve universal primary education. Under this goal, all United Nations member countries committed themselves to ensuring that by 2015, children everywhere, both boys and girls, would be able to complete a full course of primary education. This target has been explicitly mentioned in previous exam papers, so it's a high yield point. Moving ahead, the third goal focused on promoting gender equality and empowering women. The central aim here was to eliminate gender disparity in education, initially by 2005 and later by 2015. This goal is often linked with questions on women empowerment, making it another must-remember area. The fourth goal dealt with reducing child mortality. Its primary focus was on lowering the under 5 mortality rate, and examiners frequently test this goal under public health and development themes. Closely connected to this is the fifth goal, which aimed to improve maternal health. Under this goal, countries sought to reduce maternal mortality by 3/4 between 1990 and 2015, a statistic that has been repeatedly assessed in exams. The sixth goal targeted the fight against HIV/AIDS, malaria, and other major diseases. The objective was to halt and reverse the spread of HIV/AIDS by 2015, making this goal especially relevant in questions related to global health initiatives. Next comes the seventh goal, which focused on ensuring environmental sustainability. This goal emphasized integrating sustainable development into national policies, halving the proportion of people without access to safe drinking water and sanitation by 2015, and improving the lives of at least 100 million slum dwellers by 2020. Examiners often test this goal in environmental studies, so it's important to remember its scope clearly. While energy access is often associated with Sustainable Development Goals, environmental sustainability firmly belongs to MDG 7. Finally, the eighth goal aimed to develop a global partnership for development. This goal stressed international cooperation, financial aid, fair trade, and technology sharing. Questions often directly ask which MDG focuses on global partnership, making this another high-frequency exam topic. To understand the overall scope of the Millennium Development Goals, remember that they addressed issues such as extreme poverty, hunger, maternal health, gender equality, child mortality, environmental sustainability, and primary education. However, it's important to note, because examiners love this distinction, that human rights were not explicitly included as a standalone MDG. Improving maternal health, empowering women, and enhancing the lives of slum dwellers are all closely linked to the MDG framework, and this association has appeared in multiple exam questions. To help you remember all 8 goals easily, here's a useful mnemonic. Freedom from poverty and hunger, empowered by education, fosters gender equality, reducing child mortality, and improving maternal health. This strengthens the fight against HIV/AIDS, ensures environmental sustainability, and builds global partnerships. Let's now move forward from the Millennium Development Goals and understand their successor, the Sustainable Development Goals, popularly known as the SDGs or Global Goals. The SDGs consist of 17 interconnected goals designed as a global blueprint to achieve a better, more inclusive, and more sustainable future for everyone. These goals were introduced to address the limitations of the MDGs and to expand the development agenda. A key point to remember for exams is that the SDGs replaced the MDGs and officially came into force after their adoption in 2015, becoming operational from January 2016. In terms of structure and planning, the SDGs are far more comprehensive. They were adopted by the United Nations in 2015 and are set to be achieved by 2030, a timeline that examiners frequently test. The SDGs are collectively referred to as Agenda 30, another confirmed exam point. Unlike the MDGs, which focused mainly on developing countries, the SDGs apply to all countries, whether developed, developing, or poor. Structurally, the framework includes 17 goals supported by 169 targets and measured using 232 indicators, all of which are frequently asked factual questions. An interesting exam-oriented observation is that research publications related to SDGs are continuously increasing, making this agenda the most extensively studied development framework so far. Now let's briefly walk through the 17 Sustainable Development Goals, each of which carries direct exam relevance. SDG 1 focuses on no poverty, while SDG 2 aims at zero hunger. SDG 3, which emphasizes good health and well-being, seeks to ensure healthy lives and promote well-being for all at all ages, a statement that has appeared verbatim in exams. SDG 4 highlights quality education, aiming to ensure inclusive and equitable education and lifelong learning opportunities for all. SDG 5 addresses gender equality, reinforcing women's empowerment as a development priority. Continuing further, SDG 6 focuses on clean water and sanitation, while SDG 7 targets affordable and clean energy. A very important exam-tested detail here is that SDG 7 includes universal access to modern energy, increased use of renewable energy, improved energy efficiency, and ensuring energy security for all. SDG 8 promotes decent work and economic growth, followed by SDG 9, which supports industry, innovation, and infrastructure. SDG 10 aims at reduced inequality, addressing disparities within and among countries. The development agenda further expands through SDG 11, which focuses on sustainable cities and communities, and SDG 12, which promotes responsible consumption and production. SDG 13 directly addresses climate action, marking a major expansion beyond the MDGs. SDG 14, titled Life Below Water, focuses on conserving and sustainably using oceans, seas, and marine resources, a point often tested. SDG 15, Life on Land, emphasizes protecting ecosystems and biodiversity. The final two goals are SDG 16, which promotes peace, justice, and strong institutions, and SDG 17, which focuses on partnerships for the goals, reinforcing global cooperation. To better understand the evolution from MDGs to SDGs, it helps to look at their common elements, a comparison that examiners frequently ask. Goals related to zero hunger, no poverty, and gender equality appear in both frameworks. For example, MDG 1, which aimed at eradicating extreme poverty and hunger, was divided into SDG 1 and SDG 2, Zero Hunger. Similarly, MDG 3, which focused on promoting gender equality and empowering women, evolved into SDG 5, Gender Equality. These direct mappings are classic exam favorites. To make remembering the SDGs easier, you can use a simple conceptual shortcut. Goals 1 to 5 focus on eliminating poverty and hunger through health, education, and gender equality. Goals 6 to 10 emphasize clean water, energy access, economic growth, infrastructure development, and inequality reduction. Goals 11 to 15 concentrate on sustainable cities, responsible consumption, climate action, and protection of marine and terrestrial life. Finally, Goals 16 and 17 lay the foundation for peace, justice, strong institutions, and global partnerships. This logical grouping helps learners retain the entire framework with clarity and confidence. Let us now understand the UNDP strategic plan for the period 2018 to 2021, which was firmly rooted in the 2030 Agenda for Sustainable Development. This plan strongly emphasized the principles of universality, equality, and social inclusion, making it clear that development must reach everyone, everywhere. One of its central aims was to eradicate poverty in all its forms and dimensions, not just income poverty, but also social, political, and structural poverty. To achieve this, the plan focused on accelerating structural transformations that support long-term and sustainable development rather than short-term fixes. Another important feature of this strategic plan was its emphasis on building resilience. UNDP recognized that development gains are fragile and can be reversed by crises such as conflicts, natural disasters, or economic shocks. Therefore, enhancing resilience to such shocks became a priority to ensure sustainable progress. The plan also positioned UNDP as a catalyst and facilitator within the United Nations system, helping coordinate and strengthen UN support at national and regional levels. Strong partnerships played a crucial role here, with UNDP actively collaborating with governments, civil society organizations, and the private sector. The plan was designed to be flexible and adaptive, acknowledging that the global development landscape is constantly evolving and that countries face different and changing challenges. Throughout this period, UNDP aligned its work closely with global efforts to achieve the Sustainable Development Goals, particularly by promoting inclusive economic growth, good governance, and resilience building. Innovation and collaboration were encouraged as essential tools to create sustainable and long-lasting impact. Building on earlier efforts, the UNDP Strategic Plan for 2022 to 2025 reflects a more transformation-driven approach to global development. This plan is structured around three major directions of change, which are designed to accelerate progress in a rapidly changing world. To operationalize these directions, UNDP introduced 6 signature solutions, each aimed at addressing critical global development challenges in a focused and integrated manner. To ensure effective implementation, the plan identifies 3 key enablers which support countries in translating development goals into real-world outcomes. At its core, this strategic plan aims to expand people's choices, enabling individuals and communities to build a sustainable and dignified future. Strengthening partnerships remains a central theme, as achieving the SDGs requires coordinated action across governments, international organizations, civil society, and the private sector. The plan is particularly responsive to emerging global challenges such as climate change, growing inequalities, and rapid digital transformation. It promotes inclusive governance systems, sustainable economic growth, and stronger social protection mechanisms to reduce vulnerability. Climate resilience is given special importance alongside the encouragement of technological innovation and digital governance. Overall, the strategic plan for 2022 to 2025 provides a clear forward-looking framework that enables UNDP to deliver impactful, inclusive, and sustainable development outcomes worldwide. Let us now understand the concept of human-environment interaction, which explains the continuous and dynamic relationship between human beings and their surrounding ecosystems. In simple terms, it describes how humans influence the environment and how, in return, the environment shapes human life. For example, when humans clear forests to create agricultural land, they are modifying the environment. At the same time, humans depend on the environment for basic necessities such as food, air, water, and shelter. By studying this interaction, we gain insight into environmental changes, emerging ecological problems, and the important role individuals can play in protecting and sustaining the natural world. To place this concept within geography, it is important to remember the 5 themes of geography, which provide a framework for understanding the Earth and human activity. These 5 themes are location, place, human-environment interaction, movement, and region. Among these, human-environment interaction focuses specifically on how people adapt to, depend on, and modify their surroundings. This theme highlights the fact that neither humans nor the environment function independently. Instead, both exist within complex and interconnected systems. Human-environment interaction can be defined as the relationship between human societies and their natural surroundings. Both the human social system and the environment operate as intricate adaptive systems. There are constant interactions, feedback mechanisms, and correlations between environmental units and human activities. Humans continuously adjust their behavior to survive in changing environmental conditions, while environmental systems respond to human actions. This adaptive relationship explains how people modify the environment to meet their needs and at the same time adapt themselves to environmental constraints. Broadly, human-environment interaction can be understood through 3 main types. The first is dependence on the environment, where humans rely on nature for essential resources such as air, water, food, timber, natural gas, and shelter. Without these resources, human survival would not be possible. The second type is modification of the environment, which refers to the ways humans alter natural surroundings, sometimes positively and sometimes negatively. Activities such as building dams, drilling, mining, and urban development are examples of environmental modification. The third type is adaptation to the environment, where humans adjust their lifestyles, clothing, housing, and occupations according to climatic and geographical conditions to fulfill their needs effectively. To understand this interaction more clearly, we must also understand what we mean by the environment. The environment refers to the natural world and includes all living and non-living components that occur naturally, not those created artificially. In this context, the environment includes living organisms, climate, weather patterns, landforms, water resources, and natural materials that directly affect human survival and economic activity. Complete ecological units function as natural systems with minimal human interference and include vegetation, microorganisms, soil, rocks, the atmosphere, and natural phenomena within a given boundary. Some environmental elements, such as air, water, climate, energy, radiation, and magnetism, exist without clear boundaries and are not created by human activity. In recent times, Massive environmental changes caused by human actions have led to what is known as the Anthropocene, an era in which human activity has become the dominant influence on the Earth's systems. This period is marked by serious environmental challenges such as climate change, loss of biodiversity, and widespread pollution from plastics and harmful chemicals in air and water. These changes have fundamentally altered natural environments across the planet. The natural environment is made up of several key components, each playing a crucial role in sustaining life. One such component is the lithosphere, which refers to the Earth's outermost solid layer, also known as the crust. It is composed of various minerals and extends up to about 100 kilometers deep. The lithosphere exists as both continental and oceanic crust. The continental crust is thicker and mainly composed of granite, while the oceanic crust is thinner and primarily made of basalt. An important feature of the lithosphere is the presence of tectonic plates, which drive geological processes such as earthquakes and volcanic activity. Another essential component is the hydrosphere, which includes all forms of water present on Earth. This covers oceans, seas, rivers, lakes, ponds, streams, and groundwater. The hydrosphere covers about 70% of the Earth's surface. A significant portion of Earth's water, around 97.5%, is found in oceans. Only 2.5% is fresh water, out of which about 30.8% exists as groundwater. Nearly 68.9% is locked in glaciers and ice caps, and a very small fraction, about 0.3%, is available in rivers, lakes, and reservoirs for direct human use. The atmosphere forms another vital component of the environment. It is a gaseous layer that surrounds the Earth and sustains life by providing oxygen and regulating temperature. The atmosphere is composed mainly of nitrogen, which makes up about 78.08%, followed by oxygen at around 20.95%. It also contains argon, carbon dioxide, and trace amounts of other gases such as hydrogen and helium. The amount of water vapor present in the atmosphere varies and plays a crucial role in weather and climate patterns. Finally, the biosphere represents the zone of life on Earth. It includes all regions where life exists and encompasses all living organisms, collectively known as biomass or biota. The biosphere consists of interconnected ecosystems where soil, air, water, and land support life. The term biosphere was coined by Edward Suez, and it highlights the fact that life on Earth exists in diverse conditions ranging from polar ice caps to the equatorial regions. Together, these components form an integrated system that sustains life and shapes human-environment interaction. Let us now understand the layers of the atmosphere, which together form a protective blanket around the Earth and make life possible. The troposphere is the lowest layer of the Earth's atmosphere and the one we interact with most directly. It contains about 75% of the total atmospheric mass and nearly 99% of all water vapor and aerosols. This is why almost all weather phenomena such as clouds, rainfall, storms, and winds occur in this layer. The height of the troposphere is not uniform. It extends up to about 18 kilometers in the tropics, around 17 kilometers in the middle latitudes, and drops to nearly 6 kilometers over the polar regions during winter. On average, the troposphere is about 13 kilometers thick, making it the most dynamic atmospheric layer. Above the troposphere lies the stratosphere, the second layer of the atmosphere. It is located between the troposphere and the mesosphere and is characterized by its stratified nature, where warmer air lies above cooler air. Unlike the troposphere, the temperature in the stratosphere increases with altitude. This temperature inversion occurs due to the presence of the ozone layer, which absorbs harmful ultraviolet radiation from the sunday. Because of the stable temperature structure, weather disturbances are minimal in the stratosphere, making it an important zone for atmospheric balance. Moving upward, we reach the mesosphere, the third layer of the atmosphere. It lies above the stratosphere and below the thermosphere. The mesosphere begins at the stratopause, which marks the top of the stratosphere and extends up to the mesopause. As altitude increases in this layer, temperature decreases sharply, making the mesopause the coldest region of the Earth's atmosphere. Temperatures here can drop below minus 143 degrees Celsius. This layer plays a crucial role in burning up meteoroids before they reach the Earth's surface. Above the mesosphere is the thermosphere, which starts at roughly 80 kilometers above the Earth's surface and extends upward towards space. In this layer, temperatures rise dramatically with altitude due to the absorption of intense solar radiation. Ultraviolet radiation causes photoionization, making this layer a major part of the ionosphere, which is essential for radio communication. The gases in the thermosphere are stratified according to molecular weight, a region often referred to as the turbosphere. Despite the high temperatures, the air here feels cold because of extremely low gas density. The outermost layer of the atmosphere is the exosphere, which gradually merges into outer space. This layer consists of a very thin and low density volume of gases surrounding the planet. Molecules here are still gravitationally bound to Earth but rarely collide with each other. The exosphere is mainly composed of hydrogen and helium, though traces of heavier molecules exist closer to its lower boundary. It marks the transition between Earth's atmosphere and the vacuum of space. Having understood the atmosphere, let us now move to the concept of biodiversity, which refers to the diversity of life on Earth. Biodiversity is measured at three levels: genetic diversity, species diversity, and ecosystem diversity. In a broader sense, it includes the total variety of genes, species, and ecosystems present on the planet. This concept unifies traditional forms of biological diversity, including taxonomic diversity at the species level, ecological diversity at the ecosystem level, morphological diversity arising from genetic variation, and functional diversity that measures differences in species roles within ecosystems. Interestingly, tropical forests, though they cover less than 10% of the Earth's surface, host more than 90% of the world's species. Marine biodiversity is highest along the western Pacific coasts, and species diversity generally increases from the poles toward the equator, showing a clear latitudinal gradient. Within biodiversity, certain regions are identified as biodiversity hotspots. These are areas with exceptionally high levels of biodiversity, but are also under severe threat due to deforestation and habitat destruction. Hotspots are crucial for maintaining ecological balance and often contain clusters of endemic species. In India, there are 4 major biodiversity hotspots: the Himalayas, the Indo-Burma region, the Western Ghats, and Sundaland. These regions represent not only biological richness but also the evolutionary, ecological, and cultural processes that sustain life. Despite this richness, biodiversity is declining rapidly due to what is known as the Holocene extinction, often referred to as the 6th mass extinction. This ongoing extinction event is primarily driven by human activities such as habitat destruction, pollution, climate change, and overexploitation of resources. The loss of biodiversity and genetic diversity has serious consequences for ecosystem stability and human health, though many of its long-term effects are still not fully understood. To see how biodiversity functions, we need to understand ecosystems. An ecosystem includes both biotic components such as plants, animals, and microorganisms, and abiotic components such as air, water, soil, and climate. Ecosystems are defined by the relationships among organisms and between organisms and their physical environment. They exist across diverse geographical regions and support ecological balance and biodiversity. Natural ecosystems include grasslands, tropical rainforests, temperate forests, taiga, deserts, tundra, freshwater ecosystems, marine ecosystems, hydrothermal vents, and coral reefs. Each ecosystem plays a unique role in sustaining life on Earth. Finally, let us understand the concept of a food chain, which explains how energy flows through an ecosystem. A food chain is a linear sequence of organisms through which nutrients and energy are transferred. It begins with producers, such as green plants, which use photosynthesis to make food. Producers are eaten by primary consumers, which are herbivores. These in turn are consumed by secondary consumers, followed by tertiary consumers, and sometimes quaternary consumers, which are the top predators or apex predators. Decomposers and detritivores, such as earthworms, fungi, and bacteria, break down dead organisms and recycle nutrients back into the ecosystem. Unlike a food web, which shows interconnected feeding relationships, a food chain follows a direct linear pathway. For example, a green plant may be eaten by a snail, which is eaten by a frog, which is eaten by a snake, and finally consumed by an eagle. This sequence illustrates how energy moves from one trophic level to another. Let us now turn our attention to anthropogenic activities, a term used to describe environmental changes that are caused directly or indirectly by human actions. With rapid economic development and an ever-growing human population, enormous pressure is being placed on natural resources, infrastructure, and the overall ecological balance. Activities such as industrial pollution, deforestation, soil erosion, urbanization, and land degradation have emerged as serious global concerns, accelerating environmental degradation at an unprecedented scale. These human-driven changes are not isolated. Instead, they interact with natural systems and amplify environmental stress. Various anthropogenic activities have resulted in profound environmental changes. These include alterations in temperature regimes, radioactive contamination, discharge of toxic industrial effluents, excessive nutrient inflows into water bodies, and depletion of aquatic life. Human actions such as overuse of water resources, destruction of habitats, commercial exploitation of species, and large-scale construction projects, including drilling rigs and infrastructure development, have intensified ecological damage. For UGC NET aspirants, understanding anthropogenic effects is particularly important because it connects directly with themes of environmental sustainability, climate change, and ecological studies. Examining these human-induced changes helps us understand their long-term consequences on both regional and global ecosystems. When we talk about human impact on the environment, we are essentially referring to anthropogenic impact, the influence of human activities on natural systems. These impacts significantly alter ecosystems, biodiversity, and natural resources. Global warming and biodiversity loss have emerged as major threats to the survival of both human and non-human life. Environmental modification driven by human activity has led to severe consequences, including global warming, environmental degradation such as ocean acidification, mass extinction events, biodiversity loss, and in extreme cases, ecological crisis and collapse. On a global scale, activities such as population growth, overconsumption, overexploitation of resources, pollution, and deforestation continue to exert destructive pressure on the environment. One of the most significant outcomes of anthropogenic activity is climate change, often referred to as global warming. Climate change includes not only the rise in global temperatures, but also shifts in weather patterns. The primary cause of climate change is the emission of greenhouse gases such as carbon dioxide and methane, largely due to the burning of fossil fuels for energy. Other contributing sources include agriculture, industrial activities, and deforestation. These greenhouse gases trap heat near the Earth's surface by absorbing infrared radiation, leading to a gradual increase in global temperatures and disrupting climatic systems worldwide. Closely related to climate change is the issue of environmental degradation, which refers to the deterioration of the natural environment through the depletion of resources such as air, water, and soil. Environmental degradation includes the destruction of ecosystems, loss of habitats, extinction of wildlife, and widespread pollution. It is defined as any undesirable or harmful change to the environment, often resulting from human activities. Environmental concerns today largely revolve around air pollution, water pollution, degradation of natural landscapes, and the accumulation of waste and rubbish, all of which pose serious risks to human health and ecological stability. Another alarming consequence of anthropogenic activities is mass extinction, also known as a biotic crisis. Biodiversity is currently declining at an alarming rate across the globe, with many multicellular organisms showing reduced diversity and abundance. A mass extinction occurs when the rate of species extinction surpasses the rate of speciation. Over the past 540 million years, Earth has experienced between 5 and 20 mass extinction events, depending on how scientists define a major extinction. Today, human influence is pushing the planet toward another such crisis. This brings us to biodiversity loss, which refers to the global disappearance of species as well as local extinctions where species vanish from specific habitats. The ongoing decline in biodiversity is often described as the sixth mass extinction, driven largely by human activities that exceed planetary limits. The effects of biodiversity loss are often irreversible and threaten the stability of ecosystems, food security, and human well-being. Among the most visible anthropogenic activities contributing to biodiversity loss is deforestation. Deforestation involves the clearing of forests for non-forest purposes such as agriculture, cattle ranching, urban expansion, and infrastructure development. Tropical rainforests are particularly vulnerable to deforestation. Today, forests cover about 31% of the Earth's land surface, which is roughly one-third less than pre-agricultural levels. Nearly half of global forest loss has occurred in just the last century. Each year, an estimated 15 to 18 million hectares of forest, an area roughly the size of Bangladesh, are lost, with approximately 2,400 trees being cut down every minute. This large-scale loss of forest has far-reaching consequences for climate regulation, biodiversity conservation, and ecological balance. And with this, we conclude today's discussion on anthropogenic activities and their impact on the environment. We have seen how human actions shape ecosystems, influence climate, and affect biodiversity at a global scale. Understanding these interactions is essential for developing responsible environmental practices and sustainable solutions. In the next session, we will build on this foundation by exploring more concepts related to environmental challenges and conservation.